Good evening, everyone. I'd like to call the meeting to order. Pledge of the flag, please. I pledge allegiance to the flag of the United States of
America,
and to the republic for which it stands, one
one
nation,
nation,
under God,
indivisible,
with
liberty and justice for all.
Attendance, Sean.
Board Member Cole,
It's muted. Sorry. Yeah, I'm here.
Board Member Dean. Here. Board Member Kimball,
here.
Chairman Sirianni,
Here.
Board Member Weiss. Here.
Any public comments?
Not this evening.
Okay. There's prior meeting minutes. Everyone have a chance to go through them. Is there any questions on them?
Questions?
Did you say something, Matt?
No, sir. Well, I did. I said no questions, sir.
Oh, okay. Is there a motion to accept the minutes?
I'll make a motion to accept.
Jim, is there a second?
I'll second it.
Dan, roll call, Sean?
Board Member Cole,
Yes.
Board Member Dean,
Yes.
Board Member Kimball,
Yes,
Board Member Weiss,
Yes.
Chairman Sirianni.
Yes.
Motion passes.
Executive Director and General Counsel, Sean Costello.
Mr. Chairman, staff are going to report on some of their excellent work over the past month, but for now, I'd like to introduce the main event of the evening, Hazen and Sawyer presenting on the evaluation that they performed to prepare the preliminary engineering report on recommended treatment technology for the wastewater treatment plant upgrades.
Thank you for your time. We appreciate everyone's time today and the opportunity. So I'm Mark Lenz with Hazen Sawyer. I'm a vice president and the operations director for our Buffalo and Rochester offices. Been up here before when we were initially approved for the work. I've also got Micah Blate with me too. Mike is going to do actually most of the talking today. So while I've been in the business for a very long time, wastewater preliminary engineering process is not my expertise. So Mike is going to talk through most of that work. Just a little background on Hazen. We are 2,200 people nationwide. All we do is drinking water and wastewater work. So the whole company is filled with people who are doing projects very similar to this across the country. Moving forward onto tonight's discussions and things. If you click forward a couple slides, in terms of the overview, just from the schedule perspective, we were working through this. Michael will talk about the overall project, but we've reviewed a lot of the information, all of the existing information that was compiled over the last 8+ years was very useful. There was a lot of hydraulic modeling done as well as mixing modeling to help identify solutions here. We did bench testing, really appreciated the opportunity to work with your staff, both in the collection of those samples as well as using the lab space to analyze them. Hazen also maintains a lab on Manhattan University's campus. And so some of the special and more specialized testing was completed there as well. All of that resulted in alternatives analysis. The report is sitting in front of Sean, so you can see it's quite lengthy. And with that, I'll hand it over to Micah and he'll talk through things so that you don't have to read the whole report if you don't want.
All right. Thank you, Mark, and thank you everyone for the time this evening. So like Mark mentioned, we'll just jump right into the project. So like Mark said, we started the project in August 2025, working towards submitting the document there in front of Sean in late February. So the primary challenges with the wastewater treatment plant today are one, there's two influent sources of varying quality and flow. So pollutant loading and flow are quite different. The sulfide cycling, which we'll spend some time discussing here in a few slides, is challenging and causes the visible contrast. The wet weather peaking leaves minimum amount of redundancy, so how many units we can leave and take offline, are challenging during wet weather peak conditions. Chlorine usage, which I have a slide on at the end of the presentation, has gone down significantly, but at the time, historically, it has been quite expensive. Of course, you all are aware of the turbidity and visible contrast in the effluent. And we'll talk about the core mix quite lengthy here in a few slides. As you all are aware, the consent order has some major challenges with it. The existing facility is a physical chemical treatment facility, meaning that it does not currently have biochemical oxygen demand limitations. The new permit has that limitation, in addition to many other parameters of varying quality and type that warrant some major improvements. So in addition to the BOD addition to your permit, a number of other things have been added. Total sulfides is a new one. Dieldrin and cyanide are also new. But in addition to that, the DEC has proposed decreases in some other water quality parameters, such as wet testing and PCBs, namely, along with changing the frequency the parameters should be tested. So the preliminary engineering report was stipulated from the consent order to contain certain things. You can see kind of the outline of what was required in the PER. What we'll spend a lot of time on today is discussing the alternative analysis, how we went through the analysis, ended up on 2 alternatives, and finally recommending a single alternative. So we'll work through this together tonight. Like I said, we submitted the report February 27th, a few months ago, to the DEC, and we're just awaiting comments from them at this time. So this is a current aerial of the wastewater treatment plant. What we are proposing is what's called a moving bed biofilm reactor. It's moving really slow, sorry about that. Coupled to a disc filter. So you can see what it would look like in the future. MBBR on the top left of the screen, followed by what's called a disc filter for solid separation. And just kind of popping up from there is the MBBR tank. You can see there's some little waffle looking things. That's what the microorganisms grow on, and it goes inside a tank that looks like that. And that's a picture of what a disc filter is. So jumping right into the project details, we broke this up into 3 phases. Phase 1 was what we call just a baseline understanding, getting to know the plant, understanding what's already been done. Like Mark mentioned, there's been a ton of work already done, so we had a good starting point. So we reviewed historical information, conducted staff interviews, went through 4 or 5 years of historical data, did a condition assessment, development of design flows and loads. Core mix modeling is a big piece of this. We'll get to that in a few minutes. Phase 2 is where we had a big list of what we call a world of options of technologies or processes that we kind of refined down to the final analysis to make the recommendation. Okay, so there's been a ton of work already done. So thankfully, we had a great starting point. Most recently, AECOM had done a 2019 report looking at basically the biodegradation potential of the influent wastewater, and that ultimately recommended a membrane bioreactor. And a number of other studies as part of the consent, but even going back to the early 2000s, Black and Veatch had done the strategic master plan for the wastewater treatment plant. And we used a lot of this information. I mean, we built on what Black and Veatch did, a lot of the alternatives that they had defined. We kind of looked at those same alternatives. So interesting to, build on what's already been done. The draft Speedies permit does require maintaining the granular activated carbon beds. This is a huge deal. Firstly, like I mentioned, this is a physical chemical treatment plant. There's no biological treatment intentionally happening. So we need to add a biological step to get rid of the biochemical oxygen demand as step one, but we also need to get rid of a number of other parameters. It's probably a little small, but there's a number of, this is a snip of the draft Speedies permit, and there's a number of parameters that cannot be treated biologically, which means that the GACs need to be maintained for whatever treatment alternative gets implemented in the future. Phenolics, dieldrin, PCB, so on and so forth. There's a number of them that are still on the permit. So here's just a quick snip of a couple of plots that we developed as part of our development of design flows and loads. We reviewed historical data. You can see a graph of the influent wastewater flows on the top left, some BOD concentration plots on the bottom left, and some peak flow information on the right. And this is really part of the foundational understanding of the plant. You know, we don't want to over-design the plant. We don't want to under-design the plant. So this is one of the building blocks as we start building this project. You know, what is the basis of design going to look like? So this is a key part of what we do. Another important note about the facility, as you all are aware, is that it's prone to significant wet weather peak loading events. And that's just a plot there. You can see on the top right, that graph, you know, the flows at 30 and it jumps up to 60. So, you know, during wet weather events, the plant's seeing, you know, 2 to 3 times more during these peak flow loading events, which is significant. Did I?
Try it one more time. There we go.
Oh, there it goes. Okay. Oh, oops, sorry. 2 more times. Sorry. Okay. Okay, so like I mentioned, there's 2 influence sources. One is pumped, which is from the gorge pump station. It's the gorge force main. And then there's a gravity influence sewer. So this is a key point of this exercise and this preliminary engineering report is the fact that these 2 influence sources are so different. The gravity influence sewer has significant peak loading that you can see in the graph on the top left. That's a flow graphic. So you can see the average is maybe 10, 15, but then it goes up to 40, 50. So really prone to these wet weather peak events. On the right, the gorge force main kind of stays within a nice kind of plus minus because it's pumped. So there's only so much that can be pumped. So that makes sense. The other really challenging part of this is the fact that the gravity influence sewer is significantly stronger from a pollutant perspective. So that means that it's a good and a bad thing because on one hand, we're able to leverage the fact that one's weaker and bypass some of our treatment system. On the other hand, you know, we have this gravity influence sewer that's stronger. So, you know, what infrastructure is required to treat this because it is stronger? So in addition to all of the data and information that we reviewed, there's also a number of parameters that aren't typically analyzed by the plant. So we performed 2 weeks of special sampling, multiple weeks of special sampling with the Niagara Falls Water Board staff. Thanks to the staff for supporting that effort. You can see a picture of our team on the top right. That's actually in the lab at the plant. So, you know, we had a good time sampling. You can see our staff laughing and having a good time. But we performed 2 weeks of sampling to understand specific pollutants that aren't typically measured. So another important exercise of understanding kind of the basis of design. So one of the key things that we really wanted to understand is what is causing the visible contrast? Why is the color so different from the effluent compared to the Niagara River? So ultimately what we did is we collected samples throughout the plant at a few key locations. here you can see them. Don't worry about what it says, but ultimately we collected 3 key location samples, and what we found is that what's happening is that the GACs are going what's called anaerobic. They run out of oxygen, and it's producing an environment prone to grow what's called sulfate reducing bacteria. And what this bacteria does is it takes influent sulfate and it reduces it to sulfides. And if you recall from the Speedies discussion we just had a few slides ago, total sulfides is now on your permit, or it's proposed on your draft permit. So what we found is that in the influent you have some sulfate as it goes through the plant, gets to the GAC, it remains as sulfate till it gets to the GACs. The sulfate reducing bacteria then convert it to sulfide or elemental sulfur. And you can see color of the visible contrast in the chlorine contact tanks in that case. So these sulfate reducing bacteria, they are interesting organisms. They require to grow. They basically require an environment with no oxygen, carbon availability, so they need carbon to grow. And unfortunately, influent wastewater has carbon. And obviously it requires sulfate. So how do we manage this? Number one, we need to maintain an aerated environment into the GACs. Number two, we need to treat the carbon that goes into the granular activated carbon beds. So we need to bring the pollutant loading down before it goes into the GACs. And finally, we have the potential to reduce sulfate going into the facility by implementing sulfate on the IPP, industrial pretreatment program. Another way to reduce the potential sulfate reduction is reducing how much sulfate comes into the plant. Another thing that we did is a condition assessment. And this is really important because we wanted to identify deficiencies to be coupled to the major upgrade at the plant, because you don't want the rest of the plant to be falling apart while you have this major upgrade. So the idea was that we identified deficiencies throughout the plant so that they could be included in this project, so everything's kind of starting at the same point. So I won't talk through each one of these, but we looked at each system: primary treatment, intermediate pumping, and carbon treatment. And a couple key things that we found are the GAC beds need replacement, so all that carbon needs to be removed and replaced, and some other pumps and stuff. But this is all included in the costing because like I said, we want to make sure that you have a plan that's going to serve Niagara Falls Water Board the best in terms of providing like a long-term holistic strategy. So I mentioned the core mix analysis. The New York State DEC uses core mix, which is effectively a software package that looks at mixing and dilution modeling. So you can see this is a picture of the DEC's core mix model. And what this is supposed to show is this kind of green plume going up the downstream is supposed to be Niagara Falls Water Board's plume. And this is what they use to identify the proposed limits for you all. And so what we did is we reviewed their model. We have a copy of their model of all their documents. And what we did is we identified a number of challenges with their model. Number one, you can visually see that the model is assuming that your plume goes downstream, aligning with the river, right? However, you can obviously see that your plume goes upstream towards the falls. Another few big challenges associated with this model is, number one, there's a number of assumptions made on velocity and cross-sectional area of the river, which impacts how much dilution you get, which impact your BOD your wet and other parameters. So they use these assumptions to identify a number of these parameters. And so what we did is we took their model, we updated it. So you can see on the bottom left is the updated core mix model. So now it's going upstream towards the falls. And we took a Google Earth. On Google Earth, you can go back in time. So we took a couple snips back in time, 2002, 2015, and 2023. So for the last 25 years or so, the plume's always gone upstream. So number one, we wanted to make sure that we captured that in the updated core mix model. And then we used some of the same assumptions and did some sensitivity on on the DEC's assumptions in terms of velocity, depth, so on and so forth, to look at what the updated dilution factors would result in terms of total residual chlorine and the wet updates.
Maybe explain what wet is.
Oh, okay. So wet is a test that looks at whole effluent toxicity. It's basically the toxicity of the effluent in relation to organisms growing in the river, right? So you can see there's vertebrate and invertebrate. So it based on chronic and acute dilution factors, it basically looks at how things would be impacted in the river, basically. So the permit requires this testing be happen, what's called wet testing. So anyhow, so your current permit has a 3, for example, on the total residual chlorine, 3 milligrams per liter. The DEC on the draft permit has 0.05 milligrams per liter, which is effectively 0. So our analysis recommends a TRC limit of 1 milligram per liter. And we did the same thing for each one of these parameters based on the updated modeling. So the primary findings from this phase of work that we move forward with into the next phase of work are, number one, the 2 influence sources have very different characteristics. Number 2, the core mix model was used and updated to identify new recommended speedies permit limits based on updated dilution factors. You need to maintain the GAC filters because of the industrial components in the wastewater, and elemental sulfur is responsible for the visible contrast in the effluent. Okay, so jumping into the second phase of the project, now we're looking at the evaluation of alternatives. Like I mentioned, a lot of work had been done. AECOM had done a project in 2019. It had a much different focus. It was looking at the biodegradability of the wastewater. They had looked at several different alternatives, moving bed biofilm reactor, which is what was recommended as part of this work, and also a membrane, what's called a membrane bioreactor, which we'll explain what it is in a few slides. But effectively, what was proposed was an MBR, and it was going to remove the GACs. You can see in the graphic there, the biological step in the MBR was going to replace the GACs. So a couple key things about this plan. While it did address the BOD, it will not meet the current permit limits. The de-alger and phenolics, all of those things, the industrial components that we talked about that necessitate the GACs, this plan would not meet. So number one, that's a huge challenge. Number 2, it's difficult to construct. You can see this is going into an operating facility. So it would be challenging to construct this while maintaining your current treatment ability. It's going to be costly to operate and install. And membrane treatment provides a really high level of activated sludge treatment that's not required for this, for your permit in terms of nitrogen, phosphorus, so on and so forth. And it is quite complex compared to what you have now. So membrane bioreactors that's a picture of a membrane. They basically have long strands. There's different manufacturers and types, but what we're showing here is what's called a hollow fiber membrane. They're basically long strands, and the membrane basically provides a barrier between the pollutant or the particulate matter and the clean water. And what this does is it replaces the clarifiers and some types of filtration. They're a great technology. It produces a very high quality effluent, removes nitrogen, phosphorus, total suspended solids, and it allows you to operate at an intensified level compared to conventional treatment strategies. So you're getting a lot done in a smaller footprint. There are some challenges. There's a lot of pumping, and you need a lot of additional equipment, cleaning equipment for the membranes. You have to clean them periodically, and you need fine screens. So a lot of challenges and maybe unnecessary for this level of what we're looking at, since there are no nitrogen phosphorus limits, only biochemical oxygen demand. So we came up with kind of a strategy to provide a robust and defensible alternative evaluation to identify the best treatment strategy to address the consent order. I mentioned the world of options. We'll walk through how we shortlisted that and got to the final alternatives. We did some benchtop testing at our lab. Mark mentioned we have a lab at Manhattan University. So we sent some samples from the lab to the university, did some benchtop testing there, and then we did a whole modeling, desktop evaluation, costing, life cycle analysis of these technologies against one another. We started with what we call the world of options, and we put them into buckets. So bucket one is what's called the physical chemical treatment. So this is basically expanding what you have now. So right now you have physical, you have the primary clarifiers, and the GACs, and you have a chemical, you add ferric to the primary clarifiers. So bucket one is just expanding that to meet the BOD limits. The second bucket is biological treatment. And finally, the third bucket is a hybrid where we combine the physical chemical with the biological to potentially reduce new infrastructure requirements. So each bucket had multiple technologies. Physical chemical, we have a chemical oxidant. You all are familiar with chemical oxidant. You currently use chlorine. Chlorine is a disinfectant, it's considered an oxidant, a very strong oxidant. Membranes and ion exchange fit into that bucket. Biological treatment, we'll talk about these in more detail, but there's a number of different ways to achieve biological treatment, activated sludge, biofilm, enhanced primary treatment. We'll talk about most of these, and then a hybrid strategy where we combine a membrane with a reject water treatment. So step one was to shortlist the technology list. In the physical chemical treatment bucket, we removed membranes and ion exchange. Both of those produce a reject stream requiring further treatment. So we're left with a chemical oxidant. In the biological treatment bucket, we have a suspended growth and enhanced primary. Enhanced primary has limited US installs. Suspended growth requires some sort of solid separation step that can be achieved in a much smaller footprint that the BAF and the MBBR can do. Sorry, I should have said the BAF stands for biological aerated filter, which we'll explain what that is in a few slides. So we're left with those two alternatives, BAF, MBBR. And then the hybrid treatment, we have nanofiltration coupled to some type of reject treatment strategy. Okay, so like I mentioned, we took samples at the plants, or actually Niagara Falls personnel took samples at the plant, shipped it to our lab in Manhattan University. And we did a number of different tests. We did ozonation testing. So we applied ozone, which is a very strong oxidant, to the identify how much pollutant removal would be seen at a reasonable ozone dose. We found that not enough ozone could be provided to reduce the pollutants to a level that would meet the permit limits. The hybrid treatment testing determined that the nano filter does not provide sufficient pollutant removal, and also it requires reject water treatment. So twofold on the why it didn't make it to the final list. So what we end up with is the biologically aerated filter and the moving bed biofilm reactor. So those are the two alternatives where we did a more thorough evaluation, which I'll discuss now. So what is a biological aerated filter? You can see a cross section of the filter. It's effectively an upflow treatment strategy. So flows coming from the bottom, it goes through some type of media. You can kind of see the media there on the screen, the little balls where the microorganisms grow and treat the pollutants, and then flow comes out the top. We visited a bath as part of this exercise. Niagara Falls and Hazen went to visit a facility to talk to the operators, understand the operation of the system, understand the performance of the system as part of this exercise. There's a number of these throughout the US. Nearby, there's one in, the closest one, I think, well, besides the one we visited in New York, there's a very large one in Maryland. It's about two times the size of the facility here. It's been operating for decades now. So this is what the process flow would look like if you added BAPs to your system. So you would take influent, the raw gravity sewer would go through primary clarification still. The change on the influent is that the gorge flow, the force main, would now meet with raw treated wastewater. So like I mentioned, it's a much more dilute wastewater than the gravity sewer. So now we're kind of taking advantage of that and only sending the raw through the primaries. Then all the combined flow goes through the biological aerated filters. I think we need about 7. We have a slide to show how many we need. The biological aerated filters do provide a waste material. You have backwash now. From the GACs, a similar idea. There'll be some sort of backwash that you need to waste periodically. And then flow would continue onto the GACs, which is required, as I mentioned, for the permit limits. So you can see your site. This is a site plan of the plant. Can't really see so there's the 7 BAFs. They're little cells. So we would basically put this where the existing parking lot is. Like I said, we're taking primary effluent, combining it, and then it's going back through the GACs. It does require a new intermediate pump station. So the existing intermediate pump station, as part of the condition assessment, we did identify that this may require upgrades in the near future. It's at the end of its useful life. So not really a waste in installing a new intermediate pump station. You're needing it anyhow. So we're just moving the location. And then the other thing that we're doing is we're taking advantage of your existing asset. We were putting backwash supply water into the primary clarifier number 1. So like I mentioned, we did a full life cycle analysis. So we looked at how many operators would be needed, how much energy is required, how much chemicals required. And here's the findings. So you can see the energy there, 3.5 million kilowatts per year. Approximately 2 new operators required. So on an annual basis, O&M is about $1.3 million per year for this system. And the next thing that we did is we did a capital cost estimate. So
Excuse me.
sure. Yeah.
You said the operating cost is 1.3. What's the current operation and maintenance cost?
That's 1.3 million on top of existing cost.
Yes, sorry, on top of, yes, yes.
Top of the existing.
Exactly.
Okay,
Yes.
thank you.
Yep. Some of that, yeah, some of that may be the energy from the intermediate pump station. So that piece of it is included in the 1.3, so that you're already kind of pumping now. So there may be like a 30% of that that's the intermediate pump station that we did include in the analysis. That makes sense?
I'm just trying to figure out what the increase is,
Yeah.
you know, over the normal. And if you're saying that it sounds like you're saying that that's double counting some operation and maintenance costs from the pump.
From the pumps, yeah. Yep.
So are you saying it's gonna cost about 1.3 million more to run it every year
For BAF.
Yes.
They're not gonna recommend BAF.
Yeah, we aren't recommending this alternative, but
Oh,
that is what we're saying, that if you did go this way, it would probably cost about $1.3 million per year to operate it, including staff and energy, chemical.
now, are you recommending this one?
We are not.
Oh, okay.
we'll try to- we'll compare them to apples to
Yeah.
apples.
Yeah. The other thing that we did is we developed a life.
Maybe you should just concentrate on what you are recommending.
Okay, you want me to jump ahead? Yeah,
Sure, yeah.
Yeah, yeah.
Fine by me if the board would like to discuss
sure.
Let's,
any details more.
does anyone have things of what they're not recommending?
No.
See, we talked about this briefly last month. And the two questions I had, and maybe some other board members have other questions, is you get a shot at this once every 50 or 60 years, hundreds of millions of dollars. Show us why we're going to be picking a particular one. Okay, usually when you upgrade, the general rule sometimes is you reduce costs, usually. Okay, and one of the problems we have is, and I know there's some trucking involved, but the sludge waste, which keeps on escalating for us. So I want to know what is your system that you're going to recommend do? And what can we do with the sludge? I mean, if we're going to upgrade a project that's going to last 50 plus years, try to convince me why we're doing this. Or not me, I mean the board.
Yeah, of course. No, that's a good question. I mean, I think the point of the slides were to walk you through how we got to the recommendation so that you can see that we did a kind of a defensible exercise, right? So the major challenge with trying to reduce costs is that the DEC is asking you to add a number of limitations to your permit that you don't currently have. So there will be, unfortunately, be operating costs that you don't have right now that will be added because of what the DEC is requiring you to do. So all we can really do is we can say, of the alternatives that make sense, which one is the cheapest? If DEC is going to implement the pollutant, the speedies permit as is. Does that make sense?
Yeah. Do we have any thought or influence with the DEC or it's a legitimate concern?
No, it's a legitimate concern. That's why we had multiple meetings with the DEC on this, and that's why we went through the Cormix analysis on our own to show the DEC your limitations are overly stringent based on what we're seeing. So, for example, the TRC they're recommending is 0.05. We're saying it could be 1 based on our analysis.
But if I recall correctly, Sean, I mean, we've been at it for years trying to convince DEC to change those limits. And there's very slim possibility that they're going to change that.
So the draft speedies permit contains new limits. Water quality standards are evolving and they're getting tighter over time. So some of these changes are going to happen no matter what. You know, we're going to see a BOD removal limit. It's unavoidable. Every other plant is going to have them or has them already. You know, we're unique in that we're currently a physical chemical plant, but we just don't have means to treat for BOD. The exercise over the last year or so since the draft permit came out has been to revise how tight some of the limits are going to be. If the limits are as tight as proposed, they're going to require, among other things, you know, tangibly a dechlorination facility. You know, we might be able to operate the recommended process with our existing chlorination equipment and controls and meet one, which is what is being recommended, what we're asking for as part of this preliminary engineering report based on the core mix modeling that Hazen and Sawyer and their consultant performed, and some other factors that are discussed in the preliminary engineering report. If DEC accepts that, good. If they don't, then we're looking at an additional, it's about $15 million, I think is the estimate for dechlorination facilities, plus the annual cost of the chemical that's going to be used. And it creates other problematic issues in terms of meeting other permit limits, including the whole effluent toxicity and things like that. And the sulfides, because one of the ways you dechlorinate is using a chemical that is a sulfide. So if we have a limit on sulfides, but we have to add sulfide, it's kind of a catch-22. So we're trying to request the DEC make some modifications to what they've proposed, but we're not going to avoid new requirements entirely. And, you know, just like anytime you know, these new requirements are in addition to, they're building on prior requirements. So there's going to inevitably be an increase in operations cost. And essentially, we still need to operate the entire plant we currently have, plus this new biological process that we're putting in front of it. I think that there are probably some other operational costs that will decrease over time. Carbon renewal or carbon replacement frequency should drop significantly. You know, the initial
Absolutely.
batch of carbon that's going to be replaced as part of this process, it's no longer going to be the secondary treatment getting everything thrown at it. Now it's going to be a tertiary or polishing step. So it's going to last a lot longer. Its adsorption capacity won't be taken up nearly as fast. So, you know, that's something that we budget, you know, about $300,000 annually for carbon. You know, that's going to decrease. I can't say exactly how and we won't really know what our carbon renewal needs or experience is until the plant has operated for years. And we determine that we're starting to see, you know, some spikes in our effluent permit levels. So there are going to be some costs probably that are going to reduce or discontinue, but there is going to overall be an increase in the maintenance cost. And, you know, they're looking at this, they're trying to figure out to add these particular processes that we need in order to meet our permit, you know, what additional costs they're going to be. And the exercise was a little less in, you know, what costs might or might not be discontinued. Some of them are just not known.
Good. So if I understand you correctly, the recommended solution does not address the limits being proposed by DEC. It's about what it addresses is what we're requesting changes from the DEC.
No, I believe that the estimates include dechlorination
does.
facilities. Yeah, so the ultimate project cost, should DEC agree with the proposed effluent limits that we're putting forth with, you know, backup in this preliminary engineering report, will eliminate certain components. So for example, the $15 million that's currently part of that project cost for dechlorination facility, that goes away. But as of right now, you know, their assignment was to develop a preliminary engineering report
It complies with what
that would,
DEC has.
that would
to
meet,
do.
yeah, the world as it is today.
Okay.
So we're hoping for some relief, but it's also not going to be relief that slashes the operation cost in half or anything like that. It's going to help, but it's not going to, you know, eliminate the big picture things, the BOD removal that's really driving most of the cost of the upgrade.
You know, without, you know, if we're looking at $1 million plus increase in operating costs, with industry pretty much not a lot of industry anymore, and who knows in the future of industry, how is this going to affect our budget to continue to run without passing it on to residents or contract negotiations, I mean, that's a big hit. I mean, if we looked at those numbers, Sean, and how one plus million just in operating costs in today's dollars, and that always increases every year. We have 70, $80 million already in debt, right?
Right, so those operations and maintenance costs, that is exclusive of debt service. So, you know, no matter what, we're going to incur and, you know, the ratepayers are going to pay the operations and maintenance cost. It's the debt service, you know, the total debt, the total cost of the project that we're hoping to alleviate to the greatest extent possible by getting as much funding as we can for the project. Because the 1.1 million in operations and maintenance cost is probably married to, if we got $0 in financing and had to build the entire project, you know, another couple of million minimum or a few million annually in debt service costs. That would be truly catastrophic and unaffordable.
Okay, now, I know we're far into this project. I don't, my question then to you would be, you made a statement earlier as the cheapest way to go. Okay, is there something out there that maybe not as cheap, but a better system, or not an increase of 1.3 million a year? I mean, if we're spending $300 million and we could get something better, more efficient for 380 million over a 50-year ordeal, maybe we should be looking at that.
Yeah.
And, you know,
No, it's a great question. Yeah, it's a great question. This is certainly the most, oops, let me jump back and talk through the alternatives very quickly. This is going to be the most efficient and lowest cost operationally of all the alternatives that can treat for biochemical oxygen demand, like Sean mentioned, BOD. Chemical oxidant, you're going to have a recurring chemical demand, and it's going to be quite costly. And it's going to be more costly to construct, and there's limited US installations of that. So I feel like that one kind of will be significantly more expensive. Comparing the biological aerated filter and the moving bed biofilm reactor systems, the MBBR will be more efficient from an energy perspective, and it will be more operationally friendly. There'll be less operational inputs required, less instrumentation, so on and so forth. So less recurring O&M in that sense. The hybrid system, no US installations. Again, you're going to have two treatment systems. You'll have the filter membrane nanofilter. So there's more pumps. You need a pre-filter and chemical and biological treatment. So I say all that to say that this is going to be the most efficient system. So, you know, we did go through a full exercise of looking at, you know, what's going to make the most sense for you all. And certainly based on all what we know today, MBBR is certainly the most applicable technology that's going to be the easiest to operate, the cheapest to operate, and the cheapest to construct.
okay. Thank you.
Yeah, no, good question. Thank you. I think, Sean, should we just jump ahead to the recommendation maybe, or?
You've got a life cycle cost.
Oh yeah, let me show you the life cycle costs for the MBBR. Yeah, so similarly, energy is more efficient. You can see it's, you know, 5% less. Total labor hours are less than the BAF. So on an O&M perspective, 1.1 million compared to 1.3, it's still, you know, 15% savings comparably, which does add up over.
Does this also include?
It does.
Double dip on the.
It does,
Same-
yeah.
The same thing.
It does.
So the BAF.
Oh, good.
The BAF, it was 160,000 a year, the intermediate pump bank. It's 100,000 a year for the MBBR. And the reason for that is because the BAF, we have to do more, we have to raise the water to a higher elevation to work through the BAF. And so I don't know exactly what the current costs are for the intermediate pump station. the majority of the costs that we're talking about are new.
All right, thanks for explaining that.
And then of course, we have the capital costs on the bottom. So there's the direct construction cost. So this is actually what it costs to build the system, but the total estimated project cost underneath it is significantly higher, as you guys can see. So that's going to include all the overhead and profit of the contractor, the design engineering cost, insurance, legal expenses. What else am I forgetting?
On all the things that we can
Contingency.
identify as of today, right? So, the direct is essentially the things that we can cost out with direct equipment quotes. The estimated project cost is what it costs to build all the buildings around that, all the piping, connect it, anything that we can't at this very early stage identify exactly what it is and go to someone and say, give me a price for that. So, that gets you to your project cost, the low end and high end are the ranges around that are typical for this level.
Thank you for making that clear, because knowing what today's dollars, what the cost is in today's dollars. I mean, we do have a schedule on when it needs to be constructed, so.
Yeah. And so as we go forward, we'll talk about how we escalated out to what that is, in terms of.
Well,
Thank
wasn't
you.
the cost supposed to start in 28 or 29?
Yes, the total estimated project cost escalates to the midpoint of construction. So it assumes you're going to pay this over time. So it's assumed a certain inflation rate over 6-year period.
But starting in 29, was it?
Yeah, starting in because you have 2 years for design, then 4 years for construction. So it would be 2030, 2031.
Oh, okay.
Yep.
Thank you.
Yep. Just a comparison of all the alternatives. We talked through that, so I'll just jump ahead. The other thing we did, we also did a non-economic evaluation looking at, ease of operation, number of instruments, number of basins, kind of thinking about how much operation input would be required, flexibility for future and siting. So we came up with Niagara Falls Water Board staff, we came up with weights of each of these buckets, economic, operability, technical, siting, in addition to the costing, what does this look like from a non-economic criteria? And ultimately, MBBR resulted in the highest score. So we're saying MBBR has the lowest cost, is the most operational friendly, less complex to construct and operate, and it scored the highest as well. Okay, so obviously you guys know what we recommended, the moving bed biofilm reactor with the disc filter. This is what it looks like on the site plan. The other thing to think about is that this is a widely established technology and process in the wastewater industry. There are multiple manufacturers. So thinking about cost, there are multiple vendors, manufacturers, so it will be an open bid environment that will provide a competitive market, hopefully providing a lowest cost and best value to you all. And you can see its treatment capacity can also be easily upgraded as needed in the future. So we did talk about some recommendations on the Speedies permit. Sean talked about the BOD, for example. One thing that the New York State DEC added to your current permit you currently have TSS. You do not currently have an 85% removal daily minimum. So we are recommending instead a 30-day average, and the same thing on the BOD. This is a very dilute wastewater. It'll be hard to maintain an 85% removal on a daily basis. So that's another thing that we recommended in the report into the Speedies permit. And we talked about all the other alternatives already. So Mark just mentioned what we did is So I mentioned earlier, we did the condition assessment. We identified what we're calling state of good repair, or SOGR. So those improvements will bring the rest of the plant up to get rid of the deficiencies that exist now. So equipment that's reached the end of its useful life, pumps, pipes, electrical equipment to maintain service for the next 30 to 50 years, like you mentioned. So those improvements are about $40 million. And in today's dollars, the MBBR and disc filter is about $232 million. And then when you escalate it, as we just discussed, it takes it up to 336 million. And just comparing it to the other alternative from 2019, big thing is it doesn't maintain the GAC, which is required for the number of industrial components as part of your Speedy's draft permit. And it's very challenging to construct. But you can see, not only is this providing a higher level of, it provides the necessary level of treatment, it's constructible, but more importantly, it's cheaper in doing all of those things compared to other alternatives that have been proposed.
And Mike, if I could just comment on the
Yeah.
MBR. So he's just explaining, because we had talked about the MBR proposal a lot in past years. But when AECOM developed that recommendation, they were not doing it with the new draft permit in mind. So they didn't know that it was going to be necessary to keep the carbon because of new limits. And they also weren't designing it based on, any particular budget. I mean, the MBR at the time would have produced the highest quality effluent, and that's why they recommended it. It wasn't, a cost. They weren't considering costs like we are now as we face the imminent need to actually construct some of these things.
Thanks, Sean. We also recommended some additional steps. Number one, there's a resolution as part of tonight's agenda for a hydraulic study. The recommended improvement makes significant changes to the current hydraulics of the plant. So the idea is this study will confirm the existing hydraulics. There's limited information on the existing hydraulics of the system. So this study will firstly identify the current baseline conditions of the plant. We're proposing to do survey, some water surface elevation monitoring to pick up wet weather and dry weather events to really calibrate a hydraulic tool.
Excuse me.
Sure.
About the hydraulic analysis, I think when you were up here before, you said there was a significant amount of hydraulic flow analysis that you already considered. So I'm hearing something a little bit different, but maybe I'm not understanding the technical aspect here.
Sure.
So what I was referring to earlier was the mixing analysis that we looked at before. So the mixing analysis was what Micah presented, where you saw the plume visibly, right? You can see how it's moving to the left upstream towards the falls, and the DEC model showed it going downstream away from the falls. And so that was the modeling I was referring to before.
Okay.
That was extensive. This modeling here will look at what's actually happening here on site, or well, not here, but down the street on site at the plant, and how the water moves through. Because one of the key areas to save money on the overall project is taking that gorge pump station flow and not pushing it through those first primary settling tanks and taking it around that. That's going to save a lot of money in terms of sizing that system and how it operates. It's going to reduce your operating costs also, but we need to make sure that when we take it in at that point, that we size it and it can all come together there and then work the way through the rest of the process, and that no other adjustments to the intermediate pump station are needed. The reason that we're recommending to do it now is we need a lot of data to really dial in that model. So that's like 4 to 6 months probably to look at all these different flows. Like Micah talked about, the flow goes real peaky. So we need to see all of that to try to avoid going over the 100-foot weir that you guys often talk about, because that's a violation of the permit. If it happened under a condition where it shouldn't have, basically, if you don't have enough wet weather flow coming in, you shouldn't be going over that weir. So the work takes a long time to collect all the data. That's why it's like $50,000 of it is just equipment collection and surveying to make sure like we have down to like eighth of an inch accuracy, quarter of an inch accuracy through all the tanks. And then the engineering analysis. And our recommendation to do it now is because you need to understand that as you work through the detailed design. And so it's much in your favor to do that now. And then when you have the detailed design, whoever that designer is, to look at really
Alright,
the
so we're not-
design of the overall plan.
So when you say confirm, there's no data out there already telling us,
You have the
what
original
the
hydraulic
levels are.
profile from, do you remember the date on that drawing?
1972, but it's only at one condition. So normally plants will have multiple conditions on their hydraulic profile. The existing plant hydraulic profile only has one.
all right, because when I
Data
hear you
point.
say confirm, it tells me, kind of leads me to believe that there's data out there already that you're trying to confirm.
Yes, so based on a drawing from 1972
Okay.
at one condition, it works.
Okay,
We know it's 2026 and things go like this, even more so than what they did then. And so that's what we need to evaluate.
okay. Thank you for that explanation.
You want to talk about the
Sure.
derating study? or-
Yeah, and then so, I mean, these other, so that's the only one that's on the agenda, and that's the only one that's moving forward. These others are things to look at, again, on how you economize when you actually get through the design phase. So derating, that would be actually looking at potentially reducing what the DEC rates your plant for. And that might reduce the number of tanks or number of filters that you have to add. The industrial pretreatment program is again optimizing, what do different industrial sites have to look at in terms of sampling on their site before they discharge it to you? And if, depending on what they're discharging, should you have a different rate structure for them to avoid shifting the burden onto the ratepayers? Everything here has always been done on a physical chemical basis. When we start to look at BOD, that's coming mainly from your ratepayers, your residents. And so looking at that and then the rate structure study, how you structure your rates is going to be very important, that you end up with something that's equitable, because you're changing your process, you're changing your permit limits, and you also need to look at how that affects your rate so that it's equitable to keep using, I guess, the same one again.
Yeah, I just want to be careful about the derating study to make sure that we're, when you,
You don't want to
and
go.
I'm assuming
yeah.
the hydraulic study will help us
Yes, yes,
figure out that it's.
that informs everything else. Yep.
Okay.
Exactly. Yeah. Yeah, and I guess just back to your question, so, I think the core mix analysis and looking at that, and, we have had multiple discussions with DC. They acknowledge that their model is not representative of what we see as humans visually is happening. So we're hopeful that that would result in some relief based because the model that we've developed and that you have available to you now is representative of what everybody sees every day. And that would provide relief in terms of the overall cost of the project. Moving that gorge pump station flow downstream is a significant factor in terms of reducing it. And I think also looking at the operations costs and the process is very robust. Having the GAC at the end, like Sean mentioned earlier, you're not going to have to invest as much in the GAC in the future, but it's always going to be that buffer there to make sure that you're within permit limits. And so that's, I think those are probably the three main process, advantages of this that, address reliability, operability, long-term costs, as well as how do you make this as economical as you can.
So if we get some relief from the DEC, those estimated project costs will go down.
So, certainly, yes, because you definitely get rid of dechlor. So that absolutely, that goes lower, yes.
All right, so we have basically the worst case scenario estimated,
Yes,
which is
yes.
DEC doesn't capitulate at all, and that's what our total estimated cost is.
Exactly.
Yeah. As Sean's well aware, your order on consent does offer with this PER to make recommendations on what those permit limits should be. And so that's what we've done. Similar as what Mike was saying before, that 85%, that's a major one also, because on those really heavy rain days, when you're getting so much rain coming into the plant, getting 85% of the solids, there's hardly any solids in there. So getting 85% of it out is going to be extremely difficult. And that's why we're saying that shouldn't be a daily level, that should be a monthly. And that's consistent with US EPA. And there are other plants in New York State that also have that same monthly limit on that rather than a daily. So,
Thank you.
Anything else? Any other questions?
Is there any questions?
Renee,
Dan, Renee, Matt?
No question.
I,
It's just
Sorry.
that, I guess we're just in a bad spot, period. And there are no good answers. The bottom line is that I guess this is supposedly the best out of a bad situation, and we're just stuck with a bad situation. And I mean, Sean, what would it take to get DEC to move off of some of the requirements that they've added with the speedies permit?
Well,
What would we have to show them?
what we now have presented to them. So we have now Hazen and Sawyer, who has plenty of professionals there. They actually, part of this scope of work that they did under the preliminary engineering report, they got a professor from Rutgers who is an expert on mixing zones, and put together a really strong argument on why the mixing zone as presented is not representative. And then, we've gone further than that. It's one thing to say, no, you're not right, but it's another thing to say, here's a better way to go forward. So we're really optimistic that they're going to accept the revised mixing zone analysis that has been prepared in connection with this preliminary engineering report effort. And we think that there may be some openness to that. So as the board might recall, some of the board members might recall, we had anticipated that DEC was going to hold a draft permit until after the preliminary engineering report was completed. Some staff at DEC retired, a different interpretation of the order on consent came out, and they did issue the draft permit, which kind of threw us a little off balance. That said, it's been more than a year since the draft permit was issued, and we think that they may be open to some of these changes that they've been, considering some of the information that we provided. And we provided the mixing zone analysis and the chlorine decay information, which is another part of it, back in December. There's been no further action on the permit, so we're fairly optimistic that they're going to consider some modifications to that draft permit. So we've done, I believe, everything that we can do at this stage. Until the draft permit is a final permit, there's no, legal challenge where one even, possible. But at this stage, we've submitted everything we can. We've made the arguments, and we've done them in a way that, really shows, we're showing our work and, giving them scientifically valid and defensible alternatives to consider. A factor that DEC always has to consider is, we're conscious of, them regulating us. DEC is always very cautious in preparing their draft permits, I think, because they don't want to be on the defendant side of a lawsuit from an environmental group that they're not adequately implementing the regulations through the Clean Water Act or through DEC's own regulations. So I think that by giving them these, scholarly and very defensible pieces of information, we have made it more possible and more likely that they're going to be able to say yes to some of these changes.
Yeah, okay, but it still doesn't help us with raising the money for this.
No,
I mean, it does, you know what I'm saying? It does if in fact, we can get the costs down, but still, it's like, there's like no consideration about how we're going to get this money to fund this project.
well, and we certainly are going to be raising that issue everywhere we can. We've been building awareness over the past few years when we were working mostly off the AECOM report with the, at the original number was, I think, 188 million. That of course is, 8 years ago. So now, we're advanced to the point where we have, a design, part of the preliminary engineering report are site plans and, some schematics, and, we really have meat to present now. We have a real project, and hopefully that is the key to unlocking, some major funding. Another effort that is going to be, over the next weeks and months, we're going to start preparing some graphs that show what is going to happen to rates and, the potential impact on industry and residents if we don't get substantial assistance. And a very valuable part of the preliminary engineering report is there is an affordability analysis that shows that, our rates are no higher. In fact, they're less than many other municipalities, but our rate payers are less financially well off than in other municipalities. So we show that based on EPA and AWWA, both separately, two different affordability matrices, that we're already, to the point where, some of the population we serve have trouble affording their rates, and it just gets a lot worse if we don't get a lot of funding. So we're not there yet, but we're optimistic that we're really making a case now why it's imperative that substantial funding starts, coming.
Okay, thank you.
Thank you. And Board Member Weiss, I think you were asking, do we have a timeline for when the draft permit will be issued or finalized? We do not. Again, it might be on the same timeline that DEC's comments on the preliminary engineering report are, and we don't have a timeline on that either. It's likely to be months, but we have no sense of how long it'll take to get comments. But in the meantime, we're not sitting still. The focus right now is, some of these financial projections.
Okay, well, we thank you for the presentation and trying to educate us on what's going on.
Yeah,
Okay.
thanks for the time.
Thank you very much. Sean, did you say you had a few items or no?
Nothing that's imperative for tonight. Thank you.
Oh, okay. Under Finance, Deborah Zielkowski.
Good evening.
Good evening, Debbie.
So just a couple updates. We had the Tyler payments meeting last week, and the Tyler payment system is actually live. However, we need to build it out to our specifications and then work on the verbiage of what the actual statements will read. And then we'll do a soft launch, and we will be publicizing it with the press release and then inserts, and then we'll put the information on our website. So we're hoping everything goes live in May, and we'll do a demonstration for April's meeting of how it looks, what the options are. And then for finance, we're working on meeting for the shut off program. That's actually this Wednesday, and we're looking to start that in May as well. It's going to be for individuals who are more than one payment or 1 quarter behind if it's greater than $300. That's kind of like what we did last year. I think it's probably going to be something similar this year. And then we really are seeing a lot of people actually committing to their repayment plans that we have currently. So I don't really expect that there's going to be a whole lot of people on the shut off program. It's been nice seeing that everybody's working very well and just making sure that they get the payment plan on track. And so it's been great. And then the audit is scheduled to be on site the week of April 20th. And I'm still working through the depository account at this time. There's some variances I got through January through December, and there's some variances between the bank activity and the journal entries. So I'm just cleaning those up right now. And then I have to finish some of the other bank reconciliations and then get into the actual nitty gritty of the financial statements preparation for the audit.
Thank you, Debbie. Are there any questions for Debbie?
Just one. How are you doing with the journal entries? Are you finding it's easy to stay on top of, or, are they, are you always behind the curve, or do you need help making sure that the journal entries get in on time? I mean, how have you been doing with those?
So currently I'm on top of all the journal entries for the current, like January and February, except for the interest payment. So things for the interest payments, so there might be some due froms that I still have to go through. But with the interest payments, that's just very small compared to like some of the journal entries. Like the payroll journal entry is, a little bit, it used to be really challenging, but then I went ahead and I was able to fix things on the paycheck side and on the New World side so that it's cleaner to actually do. So I timed myself today and it takes like maybe 35 minutes to do the payroll journal entry. So that was like a huge thing. Understanding what the ramifications, like where the invoice is being paid and things that need to go through the depository account, like balance, like transferring some funds from the depository into payroll, just making sense of that. I did that when I did the payroll reconciliation back in January. So,
Okay, so if I heard you correctly, they're all in up through the end of February?
so all the journal entries for the most part are up to the end of January, February, yes.
Okay.
They're all in. So you can see like a good picture of the revenue and expenses. I just finished it, sorry, like this afternoon, catching those up. So I don't have any like financial statements or anything.
I'm glad to hear it.
So if I may, yes, so
Yeah.
Debbie just finished this afternoon, so I have not had a chance to bundle those up. But I do intend to send the board a budget performance report covering the first 2 months of the year, which will show revenue and expenditures. And, please just be forgiving if there's a couple of spots where there's, still zeros that look like they should have something. Because she'll fill them out. And
That
on
would be awesome.
a moving forward basis, we intend to get, and it may not be next month, but certainly likely the month after, we're going to get back in the practice of providing the board as part of the monthly board packet and the public as part of the monthly board packet, a, year-to-date budget report. So we were unable to do that for the past year or so or more, but we're going to be able to do that now because Debbie has been staying on top of those journal entries. And it really is something to be said, her working with Paychex to simplify a process that used to take a day,
Oh, it took a while. It took
hours,
hours,
and
hours.
bringing that process down to 30 minutes. So that's a significant accomplishment.
That is outstanding. Thank you.
You're welcome.
Thanks, Debbie.
You're welcome.
Mr. Chairman, I have something real quick, if I may. It's Matt.
Yes, Matt.
This is, I guess, kind of a combined question or recommendation for Debbie and Sean, because it's on the shut-off program that Debbie referenced. I know we're not quite there yet, but when my knowledge of the following is I don't know all the fine details, so you may need to look into it. But in the past, my understanding is in previous years, when we do conduct this periodic shut-off program, the meter shop that would turn people off or on again, that their working hours are, again, don't quote me on the fine print, but I know there's something to this effect that maybe could be coordinated a little bit better in the future as we approach another season of it. The meter shop's hours for turning people off, or more in particular on again, are somewhat out of sync with well, I guess they take the actual payment at City Hall. Like, for example, if I'm not mistaken, I think the meter shop stops working at 3, but our ratepayers are allowed to go pay their bill until 4. So somebody could, and it doesn't happen constantly, not every day, but it does happen throughout the program, where somebody will pay their bill, but have to remain with their water shut off for because the hours are slightly out of sync. Again, if I'm getting that partly wrong, I know it's something to that effect. So I would just put it out there ahead of time while we're approaching another shut off season. If we could maybe this time around try and have it in sync a little bit better. I know the meter shop guys have some recommendation on how to do that. I think it was authorizing, Sean would have to look into it with them, but I think they had asked in the past, could they have the okay for, it'd be technically overtime, but it's at straight time pay because they're 35-hour-a-week employees. And it would only be in the event that it was necessary so that somebody didn't have to wait overnight. Again, that's, I didn't mean to drag it out this far, but I don't know all the fine details. You'd have to ask them specifically. But maybe this time around, we could try to coordinate that a little better.
Agreed. So then that's one thing that we were discussing even today for our meeting on Wednesday is we have some people who are paying through Lighthouse platform or through City Hall, and then there is a lag. And so we don't know that they actually were there and made their payment. So there definitely will have to be some coordination with City Hall, and there would have to be some, possible like a leniency about, okay, well, you bring it in this day. And then if you don't get it there by 4 o'clock, we're going to shut you off. So there might have to be a couple, maybe a 5 to 10 day delay. We'll have to decide on how to go about that, because there definitely were some issues last year that we just need to make sure we don't repeat this year.
Yeah, there have been, and obviously you're inheriting those. We understand the difficulty there, but yeah, any recommendations you have, we would, be happy to coordinate to help with, to see that it's just a little smoother. Like I said, I know the guys that do the physical turning off and turning back on again had requests in previous years that I'm not sure if we accommodated, but well, we're not quite there yet. But I just wanted to put that out there since you broached the subject, that maybe this year around we can take a look at what they had in mind too.
Okay, I appreciate it. Thank
Yeah.
you.
Thank you.
Thanks, Debbie. Administrative Services, Caleb Holman.
Good evening.
Good evening, Caleb.
We held Right to Know hazardous communication and cybersecurity training on March 9th at the water treatment plant and on March 11th and 12th at the wastewater treatment plant. We held safety trainings conducted by WinCosh for job hazard analysis on March 17th at the water treatment plant and March 19th at the wastewater plant. And this Wednesday, March 25th, we have scheduled a loss control survey for all of our lift stations with Todd Higley of the Comp Alliance. We've created a light duty policy for workers' compensation injury claims in our ongoing effort to reduce our compensation experience modification rate and our premiums. And for the personnel actions, we're requesting to post an engineering systems technician position. This position would replace the budgeted sanitary engineer position. For the sanitary engineer, it was posted in a sponsored ad on Indeed, and we found that the majority of applicants with related experience do not have the 4 years of engineering experience required by the civil service. We're also requesting to post an accountant position for the finance department. This position would replace the budgeted deputy director of financial services position. Through my discussions with Debbie, she feels that the workflows of the accounting side of the financial services department have increased and resulted in a need for an additional position. It'll also allow Debbie and our staff accountant to transition tasks, bringing them up to take on higher level duties. And lastly, we are requesting to post an operator trainee position to fill a vacancy due to the pending resignation of one of our wastewater trainees.
Okay. On number 1, is there a motion to approve number 1?
Make the motion.
Is there a second?
I'll second it.
Dan, Jim, and then Dan. Any discussion on it?
Yeah, this is Matt. Sorry, I'm working off a very small screen. Could you just remind me, please, what is number 1? What's this vote on?
Engineering Systems Technician.
Okay.
You want to explain that, Caleb?
Sure. Like I said before, we currently have posted a sanitary engineer position. It was on a sponsored Indeed ad, and we found that the majority of applicants that we're receiving with related experience just don't quite have the 4 years of engineering experience required by the civil service. And it would be a slight downgrade in position in order to gain an applicant with applicable experience.
Understood. Thank you.
Okay. There being no further questions, proceed to vote. Roll call.
Board Member Cole,
Yes.
Board Member Dean,
Yes.
Board Member Kimball,
Yes.
Board Member Weiss,
Yes.
Chairman Siriani.
Yes.
Motion passes.
Number 2, an accountant.
Motion to approve.
Is there a second?
Second.
Renee. Any discussion on it?
I have a quick item, Mr. Chairman. Just for clarity, I was listening, Caleb, but I was a little unclear. Is this eliminating a different position or along with creating it? Or just rephrase in simpler terms what exactly this
Certainly.
does.
Our Deputy Director of Financial Services position is still in
Yeah.
the operating budget for 2026. It would be replacing that position.
Okay, and it's a new hire? Or are we putting somebody in that
Well,
position?
we would follow the internal posting requirements outlined in the CBA. So it'd get posted internally first. And then if we did not find any qualified applicants internally, we would post it on Indeed.
And if I may just interrupt, so accountant is a civil service classified position. Upon the board's approval, we will request that civil service schedule the accountant exam. So the appointment will be a provisional appointment to begin with, and then the test, whenever that comes up, will be offered, and we'll hire from that list.
Okay, thank you. And then Caleb or either of you guys, but is the intention behind, I'm not against the idea, I just want to understand it a little better. Is the intention behind eliminating one and sort of recreating it as an accountant position? Is that for a cost savings? Is it need-based? Why exactly are we doing that?
So in my discussions with Debbie, she feels that the workflows in that particular part of finance have increased to the need of a new position.
I see. So she feels there's a need for the accountant position more so than filling it at some point or not with a deputy role.
Yes, sir.
Understood. Okay, I'm good then. Thank you, Mr. Chairman.
So you're
You're welcome.
So we're proposing that we're eliminating the deputy position.
No, we didn't
Replace it
propose
with
it.
account.
I think we just took, because it's in the budget, we moving that money over to the accountant position. And we're not eliminating it. We're just adding an accountant using the deputy money.
But it's,
Which-
it goes unbudgeted, right?
Right, yeah, so this would remove funding for Deputy Director of Financial Services, and that payroll instead would be allocated to the accountant.
Yeah, which it is a little bit of a savings. I don't know what it
Actually,
is.
yes, it is a savings, a modest savings.
Yeah,
But then this is Matt, but then technically the line item for the deputy position remains in existence but unfunded. Am I understand that correctly? It's a little bit of
So we're a little different than like a municipal
weeds.
city budget where positions are, carried from year to year, but not necessarily funded. The board
Mhm.
has a more flexible structure. So, in this case, the board can add a deputy whenever it wants, but in this case, there wouldn't be any budgeted money available. So we're not going to show a vacancy. Next time we update the organizational chart, we're not going to have a blank box for deputy director. We just won't show it because it's not
But we're eliminating the position then.
Yes.
Okay.
In that sense, yes.
Okay. I mean, it's maybe a little bit in the weeds, but it's just important for me, and I think I'm not the only one asking, just to understand exactly what it is we're doing with the vote. So it's not just moving the money, it is in fact eliminating the position and then using those excess funds to hire an accountant, create the position.
That's correct.
Okay.
Thanks, man.
Okay.
I appreciate the questions and the request for clarity.
Yeah.
roll call, Sean.
Board Member Cole,
Yes.
Board Member Dean,
Yes.
Board Member Kimball,
Yes.
Board Member Weiss,
Yes.
Chairman Siriani.
Yes.
Motion passes.
Number 3,
Motion.
operator trainee. Is there a motion?
Motion to approve.
Jim, is there a second?
I'll second it.
Dan, any discussion on it? Roll call, Sean?
Board Member Cole,
Yes.
Board Member Dean,
Yes.
Board Member Kimball,
Yes.
Board Member Weiss,
Yes.
Chairman Siriani.
Yes.
Motion passes.
Okay,
Thanks, Gil.
thank you, Caleb. Engineering, Doug Williamson.
Good evening, board.
Good evening, Doug.
Okay. Once again, I've got 3 annual reports required by our speedies permit that are due at the end of this month. The first one, the LaSalle SSO annual report that's submitted due to the requirements of New York State DEC order on consent. in 2008. Basically, you know, trying to document how we're going to mitigate SSOs in the LaSalle area. So part of that, after the mitigation activities are performed, there's a flow analysis that's performed, and we've currently got that scheduled with Tech Smith in March. Typically, they look at the the reductions in the flows and determine that certain activities are mitigating SSOs. So Arcadis also, as you're aware, last year they performed the phase 2 and 3 SSES work, and they recommended activities for us to perform this year, and then there will be a post-construction monitoring next year for those activities. The next annual report due is the PCB MP annual report that monitors PCB levels in the sewer system and at the wastewater treatment plant. The goal, obviously, of these reports are to reduce levels in the facility's discharge, but we've had no permit violations with PCBs since 2014, but it's a requirement. Final report that's due is the MS4 annual stormwater report that's done on N-Forms on the DEC website. It's submitted to demonstrate compliance with our stormwater management permit, and it basically details the activities that were performed during the reporting period to reduce the discharge of pollutants to the maximum extent possible. And also, I'll be attending the Western New York Stormwater Coalition meeting on Tuesday to discuss, to learn more about permit compliance items. As mentioned at the last board meeting, we received a report from Encoris regarding the corroded 30-inch backwash, cast iron backwash pipe that's located in the basement of the wastewater treatment plant. The report recommended that we just recoat the pipe and put in new pipe supports at a cost of about $10,000, so there won't be a resolution required this month. Onto the water main projects, kind of a busy season for that. We had a pre-construction meeting with CPL and Malvastuto Construction this morning regarding the West River Shore water main replacement project. That bid opening will be here on Friday, and we're hoping to have a recommendation of approval at the April board meeting.
Mr. Williamson, I think you mean the West River Shore bid was awarded. That was the kickoff meeting.
Is that what I said?
It was already got the.
Oh, I'm moving on to my next item.
Yes, you're on
my
another
list.
water line project.
Okay, I'm sorry. On that project, they plan on starting on Monday or by Monday, and they plan to start excavating test pits. I'm sorry, I don't know how I
That's
did
all right.
that one.
It's all right.
Okay, there's a so the bid opening for Laughlin Drive, Woodcop Avenue, and 85th Street Loop, that one is Friday, March 27th. And that one is the one that's going to be recommended for award in April. And then there's also 3 other water main replacement projects out for bid currently. First one being the Beach Avenue Water Storage Tank Rehab Project. Second one being the Beach Avenue Booster Pump Station Project. And the third one is the 20th Street Water Main Replacement Project. All those bid openings will be on April 17th. And hopefully those ones too will have a resolution to award in April. So it's very busy. I don't think we've ever had so many projects, especially on the water side, being awarded at a board meeting. So that'd be 4.
And that's partly because we're spending grant money before it expires. So we're moving quickly on some of these to get them done, address some problematic mains. At next month's board meeting, we will have a brief presentation on the Beach Avenue plan. So that's a major project. It's going to have a significant beneficial impact on particularly the northern end of the city. So I think it'll be good for the board to understand the benefit that's going to come from that project. I don't know if I will just deliver that update or if we'll have the engineers discuss.
Okay. Are there any questions for Doug? Thank you, Doug.
Yep, sorry, I got confused. So many little
That's all
projects
right.
going
All
on.
right. Information and technology, either Jonathan or Alton.
Good evening.
Good evening.
I'm happy to report that CISA and Dartrace found no high vulnerabilities during their last scan. With that, though, New York State came out with a list of cybersecurity requirements for water and wastewater that they're implementing because of the ongoing world and the conflicts. I've been in a couple of webinars with DEC about how water plants and authorities and electrical are under attack by cybersecurity. With these requirements, the one that we have to do right away is report any compromise within 24 hours to DEC, and then we have some other times, some more times to implement the other ones. The good news is we have already been doing that for a while, hardening our cybersecurity. One thing that we started rolling out is two-factor authentication for all users now. We've been doing that in groups. So we actually call them the power users first, who are proficient, so we could also figure out how to service them if they have an issue going in there. And we also did the self-service reset portal for the users because there's going to be more lockout of accounts. With this though, there is grant money that I've been working with finance that we could get to help us with some of these burdens and costs that we're going to accrue as our Microsoft licensing and implementing these security. We also training. I worked with HR to do some cybersecurity training for all users. And with finance, with the new payment system, there's an IVR system, which is the interactive voice response where they can actually pay their bill with a credit card over the phone. It's not live yet, but I was able to daisy chain that to our IVR. So it would make it easier for people to make their payments over the phone. With that, we have a test environment that we're constantly testing new software, and the backups, a new backup solution that we're trying and we're testing with the vendor, so it'll be a faster recovery time if we had not a cybersecurity threat or just a disaster recovery. Lastly is just the UPSs. The UPSs down the street were end of life, and when we had issues with National Grid, it would throw the virtual machines off. They have to reboot. Usually we get a call for operations. So Elton's been working with Motion AI to get a couple quotes so we can replace those battery backups and even monitor them over the network so we can see how much time we have and when the batteries are shot and implement a better maintenance schedule for them. So that's everything we've been doing.
Are there any questions for Jonathan?
Mr. Chairman, if I could just add one thing to what
Yes.
Mr. Joyce was saying. So these cybersecurity regulations, they are separate sets of regulations that are largely similar for DEC and Department of Health, which of course we are regulated by both entities, being a drinking water and a wastewater system. They're first in the nation cybersecurity regulations. There are, little analogs to them in other states, but it was extremely gratifying to read through those regulations and to compare all the work that IT has been doing to upgrade firewalls and, all the unseen backbone steps that they've been taking. We're positioned much better probably than many other systems. And I'd like to express my appreciation for Mr. Joyce and Mr. Mensa-Selby's efforts.
Thank you.
Thank you,
Thank
Sean.
you very much.
Thank you, both of you. February 2026 operations and maintenance report, Sean, have anything?
No, Mr. Chairman, if there are any questions, I'm happy to take them now or after. And there's also an update from our government relations firm on their activity. We're going to continue to make sure that we're apprising the board of their activity through that monthly update report.
And the E3 communications?
Yes.
Okay. Resolutions.
Mr. Chairman, the first resolution is found beginning at page 37 of the agenda packet, Resolution 2026-03001, election of officers and committee chairpersons.
Is there a motion?
Mr. Chair, I'd like to make a motion to extend the board member appointments of officers and committee chairpersons accept that Mr. Weiss is appointed as the chairman of the Executive Staff Review Committee.
I'll second that motion. Is there any discussion on it? Roll call, Sean?
Board Member Cole,
Yes.
Board Member Dean,
Yes,
Board Member Kimball,
Yes,
Board Member Weiss,
Yes.
Chairman Siriani.
Yes.
Motion passes. The second resolution is found beginning at page 39 of the agenda packet.
Is there a
Resolution
motion?
number 2026-03002, accepting proposal for wastewater treatment plant hydraulic study.
Is there a motion?
motion to approve.
Is there a second?
Second it.
Any discussion on it? Sean, roll call.
Board Member Cole,
Yes.
Board Member Dean,
Yes,
Board Member Kimball,
yes,
Board Member Weiss,
Yes.
Chairman Siriani.
Yes.
Motion passes. The final resolution in the agenda packet is found beginning at page 47, Resolution 2026-03003, accepting proposal for wastewater treatment plant uninterruptible power supply replacements.
Is there a motion?
move it.
Renee, is there a second?
second.
Jim Dean. Any discussion on it? Roll call, Sean.
Board Member Cole,
Yes.
Board Member Dean,
Yes,
Board Member Kimball,
Yes,
Board Member Weiss,
Yes.
Chairman Siriani.
Yes.
Motion passes.
Any unfinished or old business? Any new business or any additional items for discussion tonight? No executive session is needed. Is there a motion to adjourn?
move it.
Renee,
second.
Jim, Dean, roll call?
Board Member Cole,
Yes.
Board Member Dean,
Yes.
Board Member Kimball,
Yes.
Board Member Weiss,
Yes.
Chairman Siriani.
Yes.
Thank you.
Thank you. I know it was a lengthy meeting. I apologize. But we did ask for the two young men to come in to try to explain to us. We'll just have to yell at Sean for having it too long.
Matt?
No, I'm glad that they came in. It was
Yeah, I
information.
know. We all are.
We needed it.
Enjoy your vacation, Matt.
It's a make-a-wish trip for my nephew, but thank you. We will.
All right, I'm sorry.
No. It's okay.
Enjoy the trip.
We'll enjoy it, and I'll see you guys next month.
Thank you, everyone.
Sorry.
Thank you.
That was so long.